Okay, we're going to look at solving log equations. I'm going to try and be a little bit more upbeat this time around, so maybe you won't be as bored. Okay, so we know how to solve exponential equations, and if I gave you something such as 3 to the x equals 27 to the 2x, we would know to rewrite it using the same base. So 27 is 3 cubed to the 2x, and then we have the property that says if the bases are the same, the base is 3, then the exponents must be the same. Okay, well, the same thing is true with logs. And in a log, we say that if the bases are the same, in this case 5, then the arguments must be the same. So in this particular problem, since they both have a base of 5, we would say 5x plus 9 equals 6x. Subtract 5x, and that leaves you with x equals 9. And that is it. If the bases are the same, the arguments must be the same. All right, so the next example, they both have a base of 2. The argument 1 minus 4n, the argument 2n plus 43. Those must be equal. Equal base, equal argument. Oh, you know what? Right up here. I kind of skipped over that, didn't I? So 1 minus 4n equals 2n plus 43. And now this is a basic algebra equation that you know how to solve. Let's add 4n to both sides. 6n plus 43. Subtract 43. And that would give you negative 42 equals 6n. Divide by 6. N is negative 7. Equal base, equal exponents, equal base, equal arguments. Okay, so you look at number 3, and the problem is this 1/2 in the front. So they both have a base of 6. Argument is 25. Argument is 23 minus 4w, but the problem is this 1/2 in front. So before I can say equal base, equal arguments, I have to move this 1/2 up. That's the power property of logs. So this is now going to become the log base 6 of 25 to the 1/2. Okay, so 1/2 power is a square root. 1/2 power is a square root. That's going to become 5. So this is the log base 6 of 5 equals the log base 6 of 23 minus 4w. So the bases are the same, the arguments, therefore, must be the same. So 5 equals 23 minus 4w. Subtract 23, I think that's negative 18. Divide by negative 4, and that is positive 18/4, which does reduce to 9/2. Always reduce. You will lose points if you don't reduce. All right. So 4 is pretty similar in terms of we got these equal bases. And by the way, no base, therefore the base is, you got it, 10. I've got 3 logs. It's one too many. I could say, well, 4 equals 72, but it doesn't help me. I have to use my properties. Add logs, multiply the arguments. So this becomes the log of y plus 5 times 4, product property. Add logs, multiply arguments. So I got to combine this first before I can do the whole equal base, equal argument deal. Okay, so my argument is 4 times y plus 5, and that equals 72. Whoa, what happened to the logs? There's a property. If the bases are the same, then the arguments are the same. 4y plus 20 equals 72. 4y is 52, and y is, how about 13? No. Yes, I think. Yeah, 13. Okay. So number 5 requires a bit more work. Great. Bases are the same. Arguments must be the same. So I'm going to end up with m squared equals 18 minus 7m. Okay, so now we're at a point in your math career where you kind of have to remember everything that has happened previously. This is a quadratic. You want to solve a quadratic, which, by the way, is a parabola. Set it equal to 0, do your diamond, factor, and solve. So this is going to become m squared plus 7m minus 18 equals 0. Make your diamond. That would be 9 and negative 2. The lead coefficient is 1, so I can shortcut it. Oh, I wrote n, m, n, my goodness, whatever. M is negative 9 and 2. Okay. All right, so number 6, you have to have like a log of blah equals a log of blah. You can't have this addition sign going on. So first thing I need to do is add logs, multiply arguments. Now I have a log equal to a log. They both have base 10. So you get 2k squared equals k squared plus 16. Subtract k squared from both sides. And k is going to equal plus or minus 4. And that is when you have a log equal to a log. Okay. Well, sometimes it's going to be a log equal to a number. Yesterday's notes or whatever day, you have the log base b of a equals x. And you converted, and it was b to the x equals a. We're going to convert forms for all of these. There's no log on this side. So we can't just say, oh, the bases are the same, the arguments are the same. There's no argument here. I'm sorry, here, you can't see what I'm pointing to. There's no argument on the right. We're going to change forms. This is going to become 2 to the 6th equals x minus 4. So 2 to the 6th, that's 2, 4, 8, 16, 32, 64. That's 2 to the 6th. Add 4. Okay. We have to isolate the log. So first thing I'm going to do is add 7 to both sides. How about 4? Okay, so I've isolated the log. We've isolated the log. There's no log on the right. It does not say the log of 4 or anything else. There's no log on the right. Change forms. So the base is 3. The exponent is 4 equals the argument. 3 to the 4th is 81. Okay, subtract 8. 73. I think 81 minus 8 is 73. Yeah. Divide by 4. 73/4, which seems like a really strange answer, and that might be wrong, but I don't have a calculator handy, and I'm not going to pause and figure it out. Okay, 13. So for 13, we have two logs. Add logs, multiply the arguments. Base is 10. You have a single log, change forms. 10 squared equals 2x times x minus 5. That's 100. All right. You have a quadratic. Squared is a quadratic. Set it equal to 0 and use the zero product property. So this is going to become 2x squared minus 10x minus 100 equals 0. I don't want to factor with that. It's too big. I mean, I could make my diamond, but it's way too much. So instead, how about we take out the 2? That's x squared minus 5x minus 50. And notice what happens now. A is now 1, so I'll be able to shortcut it. So that's going to be negative 50 in the top, negative 5, and I'm thinking negative 10 and positive 5. Yeah, so 2, and I can shortcut it, x minus 10, x plus 5, zero product property, who cares about the 2? X equals 10 and negative 5. All right, last one. Bring the 2 up, so that becomes the log of x squared minus the log of 4 equals 2. You cannot change form until you have a single log, so you got to combine that, then you can change forms. Subtract, divide arguments. Don't divide logs, divide the argument. The argument's x squared, and the argument is 4. Base is 10. Change forms. 10 squared equals x squared over 4. All right, so multiply both sides by 4. That's 400, I believe. Okay, and square root, and I believe that's 20. So it's plus or minus 20. Okay. But now there's a problem. So we need to go back and we're going to adjust a couple of these answers. The argument of a log must always be greater than 0. Always. It's the domain. So if you go back and you check, let's look at number 14. If you go back and you check number 14, if you plug in negative 20, that would give you a negative argument right here. It would become the log of negative 20, and that's never allowed. An argument must always be greater than 0. So I'm going to adjust, and this is not going to be plus or minus 20. It is just going to be 20. Number 13, let's go back and look at 13. If you check x equals negative 5, you plug that in right here. You get the log of 2 times negative 5. Well, that's negative 10. No can do. So negative 5 is not a viable answer. And I think the number 7 and 8 are okay. And then let's go back here. Anywhere where we got 2 answers. So let's look at number 5. Let's look at number 5. I think number 5 is okay, and here's why I think it's okay. When you take negative 9 and you plug it in, negative 9 squared is 81. That's positive. We're okay. And then 18 minus 7 times negative 9, that's positive. That's okay. So in this case, they both work. So maybe you want to make note to yourself somewhere at the top, on the side, wherever. But the argument It must always be greater, not or equal to, but greater than 0. I think one of these is a highlighter. Yeah, there we go. All right, that is solving log equations.